Okay, I see there are a lot of presentations being uploaded. Are there still people that need to upload their presentation? I give two more minutes before we start. Any problems with uploading? No? Okay. We start in 1 minute. Okay, welcome everyone. So the presentations will start. So again, 3 minutes. I follow the order of Meet Echo. It's almost similar to the data tracker, but I see some small changes. So I will also announce the next speaker when the current speaker starts. Right, so we start with augmenting augmented by edition. So is the speaker here in the room or remote? Nobody's speaking up. Also remote. I don't see any people here.
Hello?
Oh, right. Excellent. Yeah. Please go ahead. Start your presentation.
Okay. So I'm going to present our projects of draft augmented by addition into the IETF YARN library. Next slide, please.
You see the next slide?
Yes. So as an intro for our projects, in our draft, we have augmented the IETF YARN library to provide the augmentation list of each module. And during this hackathon, we focus on the use case of YARN push integration into Apache Kafka data mesh systems. And we aim to improve the YARN push receiver solution by directly provide the reverse dependencies in the IETF YARN library, and thus reduce the amount of time taken to find the module subscribe module dependencies of it. And the YARN push receiver, YARN push message parser is integrated in the libyarn push. Next slide, please.
Okay, next slide.
Yeah. So we'll be working on at Hackathon. We work on the implementation of this draft, and we aim to prove that with the feature proposed in our draft, we could provide a lightweight solution for finding reverse dependencies, which is required for the network management closed loop operation. And we plan to create a Docker image for net-to-peer tools with the feature implemented so everyone can test and use it. We will implement the find dependency solution with the feature proposed by our draft. Next one, please. During the last hackathon, we have implemented the features, and for this one, we will wrap it into Docker, and we'll also integrate in libyarn push the find dependency solution. Next one, please. For the net-to-peer-to Dockers, by connecting to the net-to-peer-to server in this Docker, user can query it in libyarn push and get the augmented by list directly. Next one, please. And this is a screenshot of the Docker file, and you can find the link by clicking on it, the name. Next one, please. And this is a screenshot of the net-to-peer-to server query the IETF interfaces module and the outputs of YARNlib, the YARNlib content of it, and we can see the augmented by list. Next one, please. For the libyarn push, we have the find dependency solution is implemented to use the YARNlib content to find the reverse dependency, which is the augmentation and deviations. And compared to the previous solution we used, which is the get all schemas, we have avoided getting all the schemas when during the netconf session establishment, and can reduce great amount of time. Next one, please. And libyarn push will firstly pass the subscribe filter to get the subscribe module. Next one, please. And here is the, and then we'll send a get request to the IETF YARN library to get this list. And then they will show that, know that this module is augmented by the IETF IP and IETF network instance. Next one, please. We can reduce great amounts of times by avoiding the get all schemas, because according to the Cisco XR published YAM modules, it has more than 1,000 modules, and download that's for each for parsing each YAM modules will cost great amounts of time. Next slide, please. And that's the links and information of author. Thanks.
Thank you. Thank you very much. So next presentation is the sustainability insights. And after that, possible attempt to use Sconepro. So first, sustainability insights.
Can I use the mic?
Yeah, you can use the mic. Yeah, it's all right. Set the timer 3 minutes. Well, come on. Okay, skip this. I can't manage it. Right, there you go.
Okay, so sorry.
But
yesterday you had to swallow the microphone. Now you tuned the levels.
Yeah,
okay.
I did.
Sorry about that. Try to be a good citizen. Next slide, please. I can run it myself. Yeah. So we're doing the. Do I have to
focus? I don't know what's going on. It's we have
not current deck.
We have a network problem, maybe. Normally we are connected here.
So I'll just have to whip out the whiteboard.
Oh, here.
Okay.
There we go.
So we're doing sustainability insights, getting sustainability metrics from the network, so the operation of the network, to do lifecycle analysis to be able to get the carbon footprint of the operations. So that is not taking into account concrete that built the actual data center, but the operational levels of power draw, for instance. You can imagine that you want to have equal playing field, then, so you can compare different numbers and know what's in the numbers. So if someone asks, like, is the cooling included in the power draw, you can then confidently say yes, it's included or not. And then to compare different equipment in the network on the metrics. The end goal then is to decrease energy consumption and then increase the awareness of the power draw, climate impact. To do this, you can correlate the power draw with energy mix, where it's coming from. As you can see here, this hackathon is using the Sustainability in a Box open source project. What we did now is to replace this SSH collector that logs into some device and does a show config to get the metrics, to do a Yang push collector instead. So what we did, instead of having hardware to do this, we created a simulated device that published the model, the PowerF model, via Yang push, and we hacked NC client netconf library to be able to get Yang push, and then added a Yang push collector to this pipeline. That was basically it. The interesting drafts are in the box on your right, and the projects are published on GitHub. If this is interesting, please come by the green buff on Wednesday in Regency C/D at 1 o'clock. Thank you.
Thank you. Thank you. So, okay, the next presenter is a possible attempt to use Sconepro. Is that in the room?
Remote, hello?
Okay, thank you. And the speaker of that is ILNP. I know it's in the room. Okay, there you go. Yeah, please go ahead.
Good afternoon, everyone. Today I will be presenting our work on using Sconepro for RTC. Next. Yeah. Latency is a critical factor in RTC. High latency can decrease the user experience in applications such as video conferencing and online gaming. The primary issues contributing to latency include bandwidth jitter and slow detection of bandwidth. In many cases, the detection of bandwidth changes is too slow, resulting in long latency. To mitigate these problems, a feedback pathway is needed. This pathway helps in reducing detection time and latency, thereby improving the overall quality of service in RTC applications. Next. Sconepro stands for Secure Communication of Network Properties. Sconepro is addressing a use case when the network element does intentional throttling. Our attempt with Sconepro focuses on three main aspects. First, identifying feedback information required for optimal performance. Second, developing a flow control strategy for the sender based on this feedback. And last, evaluating the effect of these strategies on latency reduction. Next. Our plan involves testing the latency of Sconepro in RTC applications. As software, we use QUIC, a QUIC protocol stack, along with Docker and Linux TC to simulate the network environment. And we have made our test repos, and the repo code will release soon. Next. The implementation of Sconepro RTC involved setting up a Docker bridge network with fixed latency and dynamically change bandwidth. Also, we use Sconepro feedback pathway to feedback information. This setup allowed us to test the impact of Sconepro on RTC and various network conditions. Next. The feedback in Sconepro involved two key metrics: capacity, the bandwidth capacity of access point; QLEN, the QLength of the AP. Based on this, we can calculate the send rate of the sender and the bit rate of the encoder. And T is a predefined empty time. Next, thank you. Our results show a significant reduction in latency when using RTC with Sconepro compared to COPA. We can see the green line of latency in two figures. The following table summarizes the frame latency metrics. Next. Our team members for this project are Jiaxing Zhang, Qinghua Wu, and Jingyu Li. Thank you.
Thank you very much. Good. There you are. The next presenter is here. And after that, we have the presentation on post-quantum IoT shield, or PQ. Here we go. All right, I set the timer. No, it doesn't work for sometimes. Another attempt. Okay. Oh, you can use the
This one? Yeah. Okay, so this is some work we've been doing across the last 3 hackathons, putting a kernel together with modifications for ILNP. ILNP is documented in RFC 6740 to 6748, and there's an ongoing project at my institution, University of St Andrews in Scotland. So for the last 2 hackathons, we've just been debugging this kernel, a FreeBSD kernel, and making sure things work properly. And at this hackathon, we managed to get it working, and we managed to get some good results between here and Scotland. And what we were doing was testing host multihoming dynamically, all controlled just by the hosts using pure end-to-end signaling using ICMP. ILNP addressing is different to IP version 6. It treats the 2 parts of the IP version 6 address, the upper 64 bits and the lower 64 bits, as completely separate. The upper 64 bits are effectively an IPv6 prefix, a locator, and if you attach to multiple networks, you can bind a node identifier to multiple locators, and effectively you are multi-homed. And so that's what we were testing in the BSD kernel. Once you've changed your binding locally, if you're in communication with a remote host, you have to signal to that remote host that your bindings for locators, your network prefixes have changed, and that uses an ICMP message. And so one of the things we really wanted to see was if that ICMP message would be able to make it across from here to Scotland, and it did. So the experiments we were running yesterday and this morning were to take iPerf, run some tests with that, with both TCP and UDP, and I've got a graph later just to show you what happens with TCP. A TCP flow is started, and then at the network level, there is dynamic multi-homing. So interfaces are brought up and down, new prefixes are discovered using IP version 6 router advertisements, and they are just added to the end host. And so the TCP flow just works over the top of these. So TCP hasn't really been modified at all to understand that it's working over multiple paths in this case. And it's just a set of interfaces going up and down. There's a sequence. We start off with one interface, then go to 2, then go to 3, then 4, then drop back down just to see that the signaling works. So we weren't after performance at all in this particular hackathon testing. We just wanted to see that the signaling worked. And this is what the results look like. Not very easy to read, I'm sorry. The graphs, the 4 at the top, show the throughput on each of the 4 interfaces. So as I said, one interface was being used throughout. Then we switched on the second one, then the third one, then the fourth one. Then we turned the fourth one off, turned the third one off, turned the second one off. And at the bottom is shown the aggregate throughput. If you're interested in any of this, I'm around all week and we'll be at the Hack Demo Happy Hour with the other people who've been working on this. And if you're particularly interested in the BSD kernel modifications, Gregor, who's not here, will be giving a presentation at EuroBSDCon in Dublin in September. Thanks very much.
Okay, so yeah, you're next. And the next speaker after here is exploring implementation process for the Merkle tree ladder. Okay. The timer doesn't work. Another attempt. No. Okay, you have 3 minutes. Okay.
I can use my phone.
No.
Oh, okay, sorry.
No.
Yeah, thank you. Just leave it. Okay, hello everyone. My name is Elias. So today I'm going to talk about IoT and how we can use post-quantum algorithms that we have.
It needs focus, yeah.
Okay. Okay, so the problem is that we always say that in the industry that S in IoT stands for security because there's not been done really much in securing the IoT devices. And now we're dealing with even a bigger problem, and that's how we can secure it against the quantum computers. So there's been lots of research going on about like new algorithm that we can use for key encapsulations, but there's not been much done to how to implement it in IoT devices. So here's, sorry, just keep skipping. So here we try to develop a draft, like a repository, so developers can use it into IoT devices. So we can encrypt the data that is passing through IoT by default. There's been lots of drafts, for example, by NIST that we have for the cryptography for post-quantum, and also some that are already discussed in IETF. So here's our repository. Please check it later and contribute to that if you're interested. So to develop it together and make it more efficient. So there are 2 proposals here. The first one, you can see that we can have like a mesh like design. So the devices that have end-to-end communication, and you encrypt it, for example, by AES, and then you have the encapsulation by Kyber, as we have developed in our repository. The second one is that we actually are developing like a hub that is we're building that on top of the Raspberry Pi. So all devices connected to the Raspberry Pi, and then we encrypt all the information that are passing through this to outside network or within the local network. So it can look like something like this, that you can configure it and you can make sure that always the data is encrypted. So we also need more lightweight approaches. There are some wars going on. We have developed a cipher called GNOME cipher. We'll push it after this IETF conference, and hopefully we can have your help to test it, because this is something that can speed up the process by benchmark by 10 times, and hopefully by your help we can make it even better. So there's been lots of lessons here. It's that I am the first timer here. I really appreciate the opportunity. The takeaway here is that IoT still needs lots of focus, and hopefully together we can focus more on how to make it more efficient and secure. Thank you very much for your time.
Thank you. Okay, so thank you. Next presentation on Merkle tree ladder mode, and after that is the responsible DNS integration. Here we go. You can try and open your laptop. Yeah, so okay, can use. Yeah, can I take your laptop?
Okay, got the first slide here. So our plan was to familiar hackathon participants with the draft we came up with, stateless hashrate signatures for Merkle tree ladder mode, and start talking to implementers about how this might work, kind of get the practical feedback into evolving the draft. Because it is a mode of operation that would impact probably resolvers, authoritative name servers, and signers to fully take advantage of MTL mode. We have our two drafts listed there. So we want to get that feedback and explore the implementation approaches. So what we did to solve the problem is we wanted to walk through how the signatures are created, and we wanted to show what it looks like. We have examples of how to do digs against a zone that's been signed with Merkle tree ladder mode. And then we had discussions with software providers. So participants were able to do the dig and see what the signatures actually look like from a live zone file from an authoritative name server. We talked them through getting an understanding of how Merkle tree ladder mode operates, so they can kind of understand that this is a mode of operation that minimizes the size impact of underlying PQC signature schemes. And then we could talk about these implementation approaches and start to explore alternatives, and in particular related to validating resolvers. So what we learned was that there's a lot of aspects to implementing a new mode of operation for DNSSEC, and particularly because of some of the things we put in our draft that really make it work well. So we need input from the implementers, the operators, and the other people in the DNSSEC ecosystem. And there you'd see an example of what a couple of the digs would give you if you dug against the live instance. The team members from VeriSign that were on it were Bert Kaliski and myself, and we had drop-by people that we had the discussions with. So with that, we're here all week and would love to have more interaction about this. Appreciate it.
Thank you very much. Okay, there's the next speakers. Excellent. And after that, we have testing congestion control. Okay. Yeah, there you go. Just test. Yeah.
All right. This one. Okay. Thanks. All right. So we are here to talk about DNS integrations, and so most of you would know that DNS domain names have been used for a variety of use cases over a number of years, going all the way back FTP, Telnet, and then we've had email and web browsing, right? But as of late, we've seen that there's a lot of new use cases for DNS domain names within blockchains and Web3 applications, decentralized social media applications, to name a few use cases. But what we would like to see, so that's encouraging, but what we'd like to see is that these integrations are done in a responsible manner. So what we did was we studied a few of these integrations that are listed on this page. But before I go into that, what do I mean by responsible DNS integration? Well, we want to ensure that any application that's allowing DNS domain names as identifiers give you the same consistent user experience that you expect. At the same time, extends the security and reliability of DNS into the application or the protocol. And so we studied Blue Sky, ENS, and Microsoft GitHub. So the first one, ENS, Ethereum Name Service, is naming application on the Ethereum blockchain that allows you to import your DNS domain names. And so once you do that, you can use that in all the applications that are supported via ENS. One of the common use cases is using DNS domain names to identify your digital wallets. The second one is ENS, I'm sorry, Blue Sky. Blue Sky is a social media application that allows you to use DNS domain names as your handles on the social media platform. And then the last one is Microsoft GitHub. They have a product called GitHub Organizations. And if you get your organization create a GitHub page and they allow you to associate your DNS domain name to the organization's GitHub page so as to build trust with your end users. And you also can verify that you control the domain name, after which you get a green check mark to show that the domain name has been verified. And so we did some measurement studies to understand if these integrations are responsible. And so you could look at our Diner 2024 measurement study presentations. So we've done a variety of presentations through the year. There's two outcomes. One is these integrations integrate with DNS in a variety of ways. And second is that there is a gap in understanding of how DNS work, and we can certainly, they could certainly use some guidance from this community. And so what we did was we wrote up a draft that talks about the guidance for integrating with DNS responsibly. Oops. So the draft talks about motivations for using DNS domain names, but at the same time, there's obviously a lot of challenges. And the draft goes into a lot of details about the challenges or considerations. The first one is the domain name lifecycle, right? So if, as we know, the domain names have a life cycle. Once you register a domain name, it can expire, it can get deleted, it can get transferred. And so how do these applications that are integrating into DNS ensure that the states are synced across and so as to avoid any security vulnerabilities as a result? For example, depending on the use case and the context, the consequences might be dire. For example, the cryptocurrencies might get transferred to someone else while you were expecting them to be transferred to you. And so as part of this hackathon, we're here to try and get feedback on our draft, which we did. And thank you very much for all the valuable feedback you've given us. And we would definitely incorporate as appropriate into our next version. we're here all week, and if you still have more feedback, we'd be happy to take it. We have our email addresses, and please feel free to reach out after IETF. And then the second thing was which working group is the right one for our draft. And I think the consensus in terms of folks we've been talking to is DNSOP is working group. So we'll keep polling for that. And yeah, in conclusion, I think that most people we talked to agreed that there is a need for having standards and best practices for responsible DNS integrations, so that current and future integrations have a path forward to integrate responsibly. Thank you.
Thank you. Hi. So next speaker is you, and sorry, I have to announce the next speaker here after, is the ultra low latency crypto. I have 2 copies for some reason. So maybe if I select the wrong one, then just please let me know then. Okay. Okay, please go ahead.
Hi, my name is Reese Enghart, and I'm talking about congestion control testing. So just to bring everybody along, congestion control is a process with which a sender works out at what rate to send. And if we're doing this well, we get better application performance as well as latency under load. Now, let's see. Our high-level plan is that we have several proposals for congestion control in different groups, and testing is important. So we want to work on test tooling and test cases. And we could also see people hacking on congestion control implementations at this table. Now, this was our first time having this specific table, and we had one test of the careful resume draft, which is in TSVWG. So this is an interop between different QUIC implementations as clients, an NS3 simulator, which emulates a bottleneck of 600 milliseconds and 10 Mbps. However, we only achieved 5 due to NS3 limitations. And so we had this long latency to get a specific bandwidth delay product. And then the sender is a Kish implementation with careful resume. And there is a jump of 400 packets. Now here's our results, all the different QUIC implementations as receivers, and Kish is our sender. The careful resume jump happens in all cases, and then there is a different number of packets being sent in the unvalidated phase. Validation happens, and so the final outcome congestion window is different in all of these cases. So that's interesting because careful resume is a sender side draft, right? So why would it make a difference to have different receivers? We're going to still be digging into that, but the bottom line is interoperability, kind of all clients worked. So next we would like to bring this table back and have more people involved and more test cases, different congestion control algorithms. And part of that is I want us to work on our elevator pitch of what congestion control is and why it matters. And then also, of course, we're going to reach out to more collaborators such as academics. That's it for now. Thank you to Gori and his remote team, Anna and Michael. And I'm Reese. I look forward to seeing people during the week.
Thank you. All right. All right, so after the next presentation, the next speaker will be the Digital Map Hackathon. Right. There you go. Please go ahead. Thank you.
Good afternoon, everyone. I'm Yumi Sakemi from GMO Cybersecurity by ERI Japan. Today, I will talk about our IETF 120 hackathon activities.
Yeah, maybe. Oh.
Okay, thank you. First, I will explain the overview of Areion. Areion is a secure and low latency cryptographic permutation based AES instructions, and Areion can be applied to encryption and hashing. For more details, please refer our internet draft. As the use case of Areion, we expected that the use case requires real-time secure communication, for example, esports, remote surgery, and so on. At this At this hackathon, we plan to measure the performance of Areion compared to the measure used cryptographic primitives. In detail, as the comparison target is AES 256 GCM and SHA 256. This slide shows the measurement conditions. As the experimental environment, we used AES-NR environment and ARM environment. And as implementation of comparison algorithm, we used OpenSSL implementation. And the measurement, as the measurement precautions, we'd like to note that the measurement range includes initialization processes. This slide shows the experimental results in the case of encryption. As shown these tables, the message length is short. When the message length is short, Areion is approximately 2 times faster than AES-GCM. The next is in the case of hashing. When the message length is short, Areion is approximately 3 times faster than SHA 256. This slide shows our considerations. From the experimental results, we found that Areion is effective when keys are frequently updated and the message length is short, for example, 32 bytes. Now we are looking for effective applications of the above features. So we would appreciate for your comments or feedback. This slide shows next step. Especially, we need volunteers that develop independent implementations. So if you are interested in our activities, please contact us. That's all. Thank you for your attention.
Thank you. All right, next presenter is you. Excellent. And this the digital map. Yeah, the digital map. And after that is the Antagonist. There you go. I think it's most safe to click.
Okay, thanks. So I'll present the results of our digital map hackathon. This is the hackathon that we plan to do over multiple IETFs, but this is the first iteration. Oh, can I make this bigger?
No, unfortunately not. No,
okay, sorry.
Sorry, you have to speak in the microphone.
Sorry,
but
okay.
It's difficult.
But I can't see the slide. Yeah. So our hackathon plan is to demonstrate how operators can use IETF topology modules to represent the real IP operator networks. And we want to demonstrate if RFC 8345 is the right approach for modeling topologies. So this is the first iteration, as I mentioned, and we will be working on improving this hackathon in Dublin. So these are the drafts that we have, and some of them we implemented, and another ones are more like informational drafts and concept drafts, etc. So you can see the list here. On the right side there, you can see kind of how we implemented those drafts. We collected things from the operator lab, from the real lab, multi-vendor one, using IETF OpenConfig or vendor-specific modules via netconf, and then we modeled it and mapped it to the IETF network-wide models. So one of the challenges going forward is how to connect those network topology modules with the IETF ISIs, for example, or some device modules which have other configuration and performance attributes. Sorry.
Make
Okay,
this
the third
larger.
slide,
Yeah,
yeah.
it would be very convenient.
This
It would
is
be
not-
larger. Yeah, sorry.
Okay, I think slide 3. Okay, I can go like this.
Yeah?
It's
Okay.
easier. Yeah. So the first iteration will be focusing on looking at the multi-vendor operator lab.
Oh, sorry.
Yeah, we used the operator lab for this hackathon, and it was Huawei, Cisco, and Juniper devices, which started with one particular problem space, how to use these models to represent a real carrier network based on the ISIS and OSPF as well, but focus of the hackathon because of the lab only had ISIS was ISIS. And the target is really looking at simulation and planning, but that is for the next hackathons. So we focused on generic topology queries first. So we started from the read-only with the goal going forward to go into simulations. And we also looked at the options and comparing the draft augmentations of RFC 8345 versus some gaps that we identified in our drafts. So we implemented multiple options. So we also started analysis and prototype, how to retrieve performance metrics and configuration attributes defined in RFC 9130, sorry, this is typo, and retrieved via device API. So node-bound from the controller via RFC 345 API and its ISIS augmentations. So this is our lab, and this is the multi-vendor lab with 11 devices. At this point, we have a discovery of 10 of those devices. For the next hackathon, we would also have Nokia planned. And we also have some simulated other 2 operator labs and 1 vendor lab. So all were discovered before, but this is the lab that we connected in real time during the hackathon. So what we achieved, we currently have discovered layer 2 ISIS topologies for multi-vendor and relationship between the layers. We mapped different device models to the network-wide topology models. We retrieved them via IETF topology API. These are the draft APIs, so we tested those draft young modules. We implemented 2 options for comparison, where ISIS areas were modeled as IETF networks, and when ISIS area is modeled as attributes, which is really something that has to be done at the moment because of limitations of RFC 8345. And we started working on how to connect IETF L3 ISIS topology to IETF ISIS module. And first attempt is by adding, augmenting the topology with some subtrees, but that's not the right approach really as a target. So we need a better approach in the next hackathon. Code is here, but we have to go through it a little bit before making it public. The lessons, we demonstrated that IETF RFC 8345 is the suitable standard for representing the multi-layer topology. We also kind of determined that operators may have one ISIS area in the domain or multiple ISIS areas in the domain. Therefore, we have to provide flexible modeling for this. In the case of multiple areas, there are limitations in RFC 345. We implemented 2 options for comparison, and we need a new RFC 345 augmentation for the purpose of connecting topology modules to other modules with young paths, defining the young paths that are connecting them. And also the challenge is how to find the right instances and keys in another module, because the keys are different. And we want to avoid duplication of the properties at network layer. These are the two APIs. The left one is the one with the areas as network. The other one is the one with without area the network. And below you can have some kind of pros and cons of each approach. And what next? For the next hackathon, we are going to add BGP, SIV6. We will separately treat topology from ISIS topology. We will add more operator labs. We will add more vendors. And we want to implement more advanced option for connecting topology to other properties in other young modules. And solution must be generic to support any other augmentations. And we also want to start working on other use cases, and current candidates are simulation or emulation. So this is the team: Oscar, myself, Benoit, Sheriff, Pierre, and Vivek. Thank you very much.
Thank you. Okay, so next, Antagonist. Excellent. And speaker after is the young push model. Yeah, young push publisher. Right. There we go. It's a little bit small, but that's very small. Can I prefer this?
Yeah, thanks. Hi, everybody. So if you are operating networks and you have plenty of network anomalies, I wanted to reassure you today, because your network anomalies now have a new antagonist, which is the name of the project, and it stands for Anomaly Tagging on Historical Data. Now, this is the third time Antagonist comes to the IETF hackathon, and it started actually because we needed to have somehow a running code validating these two drafts, which we are presenting on Friday at the NMOP working group. And these two drafts, of course, are about network anomaly detection. Okay, so why do we need Antagonist overall? So first of all, let me say that Antagonist is a label store for network anomaly detectors. The whole point of network anomaly detection is basically to enable operators to discover when something is not working as expected in their networks as soon as possible. And this is an iterative process. So we understood that there's no way you're going to get it right the first time. You have to learn over time, and you have to keep integrating knowledge into the process. And for this reason, we actually defined a semantic for exchanging data for different between different actors, different operators, different teams, and different tools as well, and a life cycle, which is actually the moments in time where these exchange happen. And it turns out that it's really, really important to have a standardized format for this, and this project is actually trying to validate this standardized format. So there are a few use cases that Antagonist can currently support. The first one is the exchange of anomaly detection labels between different operators or between different teams. And of course, as we talk about anomaly detection, we always talk about machine learning and AI. So we want to make sure that these models can actually be both human readable and machine readable, and actually feed machine learning models in different ways. So we're validating the ability of machine learning models to persist labels in Antagonist, and to actually retrieve labels from Antagonist for the retraining, with a validation step in between, where human beings can actually network engineers can actually validate if those network anomalies are real or are false positives. The hackathon plan, which is also what we actually managed to achieve today and yesterday, is basically we wanted to validate our project with real operational data. In this case, it's from cloud domain. We wanted to validate the interaction with machine learning models. We actually had a pre-trained small neural network, which we use today for the validation here. And then we wanted to also validate the support for retraining of the machine learning models, and I added partial support for the metadata filtering and search of the labels, and to fix some deployment and integration issues we are encountering. So this is the kind of architectural, these are the architectural models we currently have. So everything is deployable through Docker. We're basically modeling the 3 steps of the life cycle, which are detection, validation, and refinement. And we've done that by means of a couple of Python notebooks, which is the classical way machine learning engineers or data scientists operate with machine learning models when they play with training and retraining and stuff. And then there's a validation, which is provided by a GUI that we build, and there's a REST API which substantially supports the young model format in the drafts that I was mentioning before. And all of this is persisted in a SQL database. Just a quick example of one of the functionalities that we managed to add in this iteration, which is about the automatic generation of dashboards, just to make it easier for users to review the results provided by anomaly detection systems. And in terms of next steps, this is still very much a POC, so we're trying to make it a bit more stable for the next time, and we want to improve the scalability as well. And the very important step also is to make sure that we can validate and integrate with real network operational data. And I wanted to thank the team for the support and help.
Thank you very much. Thank you very much. Right, next slides are right. Yeah, and after this presentation, next presentation will be the thread low power. Excellent, thanks. Here you go. Okay, most safe is to click.
Okay,
yeah?
Perfect.
Okay,
Thank
I'll
you.
I'll give a visual of 1 minute.
Sure. Okay. Hi everybody. So our project is to validate configured subscriptions, young push publisher implementations, and the scope of the project was to validate different young push publishers against a young push receiver, and also in context of message broker integration. We have a repository with the packet captures and also the outcomes of the test automation and the young push notification messages, and also a testing script which we are used. These are the draft documents, the RFC documents involved in the implementations, and on the right-hand side you see the integration into the message broker, and I marked the red area where we were actually doing the verifications. Here, one example, so from Cisco iOS XR, the young push notifications, we have the push change update notifications, the subscription started and subscription terminated according to RFC 8641. Here an example from 6Wind from the subscription started messages with the different enhancements which enabling the data mesh, the message broker integration. Here from Huawei, a subscription started message. And here a push update message. So you see basically the subscribed content and also the observation time stamping and from which node this information was being exposed, and push change update messages, and also like with the state changes in the observation time stamping. Here the comparison where we are today. So we started at IETF 119 with the first implementations. Now we are at 120, and you will see in the upcoming IETFs how this is progressing. Thanks to many people who were involved, some people remotely, some people here locally. Thanks.
after thread presentation. Next one is addition into young library. All right. Okay, thanks. Yeah. It's easiest to click because this
Click that button.
Yeah, this doesn't work.
Okay. I want to start by thanking Benno and Barry and Charles for making this possible and providing this venue. And it brought together 8 people, 8 strangers who didn't know each other, never worked together before, and we learned a bunch of stuff. I think for most of us, a lot of the people had never heard of Thread before. Most of us had never done any development for embedded systems before. So we had a lot of learning to do. And I'm sure you saw on the Hackathon page, we had a bunch of interesting projects to work on. I'm just going to talk about one of them today. For people who don't know, Thread it's a lot, you can think of it a lot like Zigbee or like Bluetooth in terms of cost, power, range, performance. The big difference is Thread embraces IP, and that's why we love it, because you can take any IP application that runs over TCP or QUIC or anything else. If it runs on Ethernet, if it runs on Wi-Fi, it'll probably run on Thread. And these radios are so low power that they can last for years on a single AA battery. So Thread is really exciting. And typically these boards have a USB port that you plug into your computer for flashing firmware onto them and doing that development. And when I first saw a demo of Thread years ago, now one of the vendors from Silicon Labs or Nordic or NXP, I forget who, they showed this demo. And they had this board plugged into the USB port of their laptop, and they're using a serial program to type commands to the command line interface. And they were showing me I can type this command, and I can tell it to join a mesh, and I can do a ping 6, and look, wireless networking. And I went, that's not wireless. I can see the wire. It's plugged in the USB port. Show it to me wirelessly if it's supposed to be wireless. And so this has always been something on my mind. And today, this weekend, we achieved it. We have a TCP listener running on the thread, the open thread development environment, running on the little board, barely bigger than a postage stamp. We hooked that up to the command line interpreter's input and output instead of using the serial port, and we advertised it using DNS Service Discovery, aka Bonjour. And then in the terminal program on the Mac, I added a new browser for OpenThread, and you click on OpenThread, and then you click on whichever one you've discovered on the list you want to use, and you click connect, and now you're connected, and you can type all the same commands you would have typed over the USB cable, except now without the wire. So thank you.
Very much. Thank you. All right, so next speaker is the addition into young library. Is that remote maybe? All right. Don't hear anything. So the other one, the next, well, I would like to invite the L4S people to give a presentation. Excellent. And I will ask again for the other presentation. There you are.
Great, thank you. All right, Greg White and Cable Labs. This is the 5th time that the L4S group has held a interop event co-located with the Hackathon. And as in previous IETFs, when we've done this, we typically start out during a Hackathon event itself, and then for the rest of the week, we continue testing in the Code Lounge or some other space that the IETF provides. So same thing is happening this time. We've got the network set up, and I've done quite a bit of testing yesterday and today. And at the end of the day today, we'll be moving to another location. We'll be moving to the Brighton room, which is on the 4th floor. Invite anyone who's interested to stop by and participate there for the rest of the week. So what have we been working on? So the key components to this are the L4S congestion control architecture, which includes a congestion control implementation on the sender. It includes congestion signaling by the network in the ECN field, and it involves the receiver sending feedback back to the sender in terms of the congestion marks that were applied by the network. This is all defined in the RFCs in the box on the lower right, 9330, 9331, and 9332. And then for TCP, the feedback mechanism is being standardized in the accurate ECN draft that's listed there. Our setup this week includes a GPON network emulator with L4S support, very configurable. We can set up all sorts of different paths with different characteristics. Also, a couple of Wi-Fi access points that support L4S, which can be used for testing as well. And then the congestion control implementations. So Netflix is testing their simple rate control. There's a new open source congestion control algorithm called UDP prog that's being tested this week. We have implementations, the Apple QUIC prog as well as the Linux TCP prog. For Linux TCP prog, there are now kernel patches for Linux kernel v6, which is new as of this event. What have we gotten done so far? And again, we're just kind of getting started this week, so hopefully we'll be doing quite a bit more. And actually, I'll give a recap of the whole week's activities at the TSV working group meeting on Friday. So if you're interested in seeing more of what got done, please join us on Friday. So far, we have produced, or one of the participants produced, a new set of kernel patches for ARM, for kernel v6 Linux. The link to that in the slide that includes all the components, accurate ECN, TCP prog, and the dual pi squared congestion active queue management mechanism. And second piece is integration and testing of this new open source UDP prog. So that was just published today. The link is also on the slide there. This is a congestion control module that can be used really with any application. So running on top of UDP gives the application the ability to get this fine-grained congestion feedback from the network and get very high throughput and ultra low latency. So any application that has an interest in high throughput and low latency could pick up this implementation and integrate it into their application. And so if anyone is interested in finding out more about that and getting a leg up on getting that implementation into the QUIC developers, media over QUIC or WebRTC, that sort of thing, I invite you to come and talk to the folks at the L4S table, either here the rest of the day today or up in the Brighton room the rest of the week. This week, that module has gotten integrated into iPerf2. So anyone who wants to do network testing, testing L4S implementations can get the latest builds of iPerf2 and run testing with that congestion control module. Last two items, there was support added this week on, okay, almost done. Support for examining the state of the ECN and state of congestion control in the TCP black box logging feature within FreeBSD. And Netflix was working on validating improvements in their implementation of L4S congestion control as well. That's it. So thanks to all the team members who participated so far this weekend and who will be continuing this week. Thanks.
Thank you very much.
Okay.
So yeah, so please come along. Is there also the addition into young presentation I announced just? It's from the Benoit class group. So someone. Okay, it was double. Okay, thanks, Jorgos. I see. Yeah, you're right. It's double. Apologies. And then, yeah, up is you. And after this presentation is the DNS stuff. There you go. Okay. I give you.
Thank you.
How many minutes? Yeah.
And
It's safer to click on the
okay,
mouse. Yeah.
okay, all right.
Yeah.
So I should.
Yeah, this one.
Okay, sounds good. Right. Hello, everybody. I'm Osama from TU Dresden, and thanks to my sponsor, Confidential Computing Consortium, which is where attestation is really the enabler for confidential computing, and that's why they are funding me for this. Basically, the idea of oops, sorry. How do I? Oh, it's lagging in the okay. So the plan of the hackathon was basically that we have three different ways in which attestation can be incorporated in the TLS protocol. And the problem with TLS protocol itself, or the standard itself, is that it only provides the guarantees when the network when we assume that the endpoints are safe or secure. So basically that the keys are always protected. Under this assumption, TLS works very well. But if this assumption is not correct, meaning that if the endpoint is compromised, there are no guarantees whatsoever. So that's under that. So we have explored like three different options, which are shown here on this slide. Pre-handshake attestation, that the attestation part, which is the signing of this. Oh, you don't see also the mouse. Signing of evidence happens before the TLS even starts. So the time scale is from the left to the right. And in the second option, intra-handshake attestation, signing of the evidence, that is the claims, basically happens within the TLS handshake. And in the third option, the post-handshake, which is where TLS handshake has now finished. And after the finish of the TLS handshake, the signing of the evidence will happen. All of the three different options have their own security pros and cons and their own security properties. And the involved internet draft here is by Hannes and all, who are working towards standardizing the attestation, the TLS and DTLS. And the goals for this hackathon were specifically that how do we actually specify, and by specification I mean formal specification of the case for confidential computing. And then the second step is, after specification, how do we verify that these claims are correct? So formal verification. Okay, now I hope I click only once. Okay, and the insightful discussions, thanks to all of them who contributed to this. And what we came out with was that the overall direction of the research that we are doing is correct. That we have not only not only the development, and along with that we also have the formal verification for that. And the insights that we obtained that were not yet in the formal model is not only attestation, we have to define really what exactly is being attested. So that's something that's not really in the formal model yet. And we have a side meeting where we will summarize all the learnings that we have until now from the perspective of confidential computing specifically. And I really hope that will be interesting for the RATS working group to think more about the confidential computing side. And for the TLS working group, that's where the basically it's and RATS can be considered as one extension of the TLS. And then the WIMSE, that's working group is not specifically focused on the confidential workloads, but this will be an interesting insight for them as well. And the Lake working group also has a draft, which is extension of attestation in the ad hoc protocol. They can exactly follow the same things that the draft attested TLS is following, and the UFMRG, of course, from the formal verification side. That will be interesting for them. And I have added some links that will be interesting for you if you want to explore further.
And finally, CCC attestation SIG. The last link in there is the special interest special. I forgot what it stands for. So it's the group which is working on the attestation perspective, and it will be interesting for a few folks from RATS also to join there. Okay, so this is the internet draft which is focusing on that. So I will be here next week as well. So I look forward to the discussion. Specifically, I couldn't meet or I couldn't see many of the TLS working group people here around. So I hope that we can have some discussion around that. And thank you very much. I look forward to it.
Thank you. So next is the DNS presentation. So it's a combined one of 2, 3 presentations or projects. Two. Excellent. So you get double time. DNS stuff, as usual. They put too many things in the DNS. And the presentation afterwards is the PQ interoperability. I have 2 versions. I take the latest. Okay, it's best to click on
the arrow.
Yeah.
Okay. So it's so nice to start IETF week with meeting all my DNS friends at the hackathon and meeting all the rest of you as well, actually. There's a bunch of them on this first slide. So we had a hackathon or general DNS stuff table. I did the first thing, which is SVCB processing by, or alias mode processing by the unbound resolver. Currently, the DELEC working group is still in requirements mode, but there are already 2 protocol proposals that build upon SVCB. So they may benefit from this if they go anywhere. So Shane Kerr did implemented zone version, EDNS option in NS1. It means that you send an EDNS option and the authoritative name server reports from which zone the answer came and which version of the zone. This is just came out of working group last call and is now submitted to IESG. Jokos finalized the DNS error reporting that we've been working on for a few hackathons already, I guess. Shimon implemented the latest protocol enhancement in the compact denial of existence with the new assigned NX name code point or R-type. And Elias implemented ID key, a successor of DNS key in DNSSEC that deals with the issue that key trap. And now I hand over the mic to Johan.
Thank you, sir. So what did we do at the other table then? Well, we have this draft since a couple of years back about so-called generalized DNS notifications. And that together with another draft that builds on the same foundation, which is the desync RR set, essentially presents 2 different mechanisms for completely automated synchronization of the delegation information between a child and parent. But for this to really be useful or even understandable, we obviously need running code. So we have a name server, an open source name server written in Go. And as you can see, it says done in many of the squares there because we are really nearing completion of full support of both the notify-based automatic synchronization and the update-based automatic synchronization. There are a couple of corners left, as you can see, but most of the work is done. And then we also have various CLI tools to play with this and test stuff, etc., both in Python and in Go. So it's coming along nicely. And for those of you who are not entirely into why this is important or why we spend effort on it, this is a way of looking at it, that you have all these zones out there, and the zone maintain or make some sort of change. And in some cases, this change affects the actual delegation information. You change a name server, or you change the glue for a name server or something like that. And then you forget about it and you don't really update the parent. And the result is that you may think that you have 4 name servers, but in reality you don't, because you didn't really get it updated in the parent or something. But with this change, suddenly the child name server itself will be able to detect the change and do something about it, and on its own behalf synchronize with the parent, and then everyone just heads off for the bar and happiness ensues. So that's the plan. Thank you.
Thank you very much. So the next one is the PQ interoperability. And after that, it's the stateless OpenPGP signature verification. Okay. It's best to click up there.
Okay. Okay. Hello, everyone. So I'm going to present on the PQ and X509. So this is actually our 6th hackathon. So we started back, almost 2 years ago. Basically, the idea was to get together, test a bunch of these new PQ algorithms that are coming, and basically it's just continued to grow from there. Also, the NIST NCCOE interoperability project has actually been, I don't know why it's kind of messed up on there, but anyway, it's looking at, they collaborate with us, or they work, anyway, we kind of fit into their project, so they often look at us when we're doing testing. So that's quite exciting to be part of that. And so part of our goals, obviously, I kind of mentioned them already. One of them, gain experience with PQ algorithms, provide feedback to standards groups, obviously test interoperability. There's a bunch of drafts there, so there's lots of new drafts coming with all this PQ stuff. So we kind of give feedback, and some of us are implementing some of these drafts as well using PQ algorithms. So that's all fun and exciting. So the important part of what you're interested in is what we got done. We actually got a lot done at this hackathon, thanks to a lot of members. So the first item there, one of the new exciting things is, so we have a GitHub repository that contains artifacts. People can post them. So now there's a new GitHub action that will actually, when you post your new artifact, so say you have a new implementation of a PQ algorithm with X509 certs, it will actually run a GitHub action and then automatically run it against libOQS, which is a standard library a lot of people use, and give you immediate feedback. And we also have tooling that will then create a compatibility matrix. I'll show you a picture of that later, and it will automatically update that as well. And we will probably update that in the future as well to add other open source libraries like Bouncy Castle and that. So that's an exciting innovation at this hackathon. There's also automation scripts for building CAM recipient info artifacts that were done. We had a person join us. He wasn't here at this one. We actually have monthly meetings as well. But a lot of these new algorithms, they don't have official object IDs yet. So a person wanted to make that more crypto agile, so he made a JSON artifact format, basically a JSON format, so that you can import that, make use of that, and obviously make your testing more crypto agile. So we have that. So that's happened in between because we keep meeting as well. And yeah, we have our first implementation of composite chem as well. So that is thanks to Carl. There's still a few things that need to be done, but this is really great. So that's one of the new drafts that's being worked on. And there was some discussion about even doing some interop testing or some work with TLS with some of these like composite keys and things like that. So some work started there, but there's more work to do there. Yeah, and we had a lot of new people to join. So one of them is the major telecom of Taiwan, which is exciting. So I just got introduced to this group a couple days ago, and they joined. They created their own provider. They've submitted artifacts. They've tested against every other provider. I think there's 12 or 13 of them now, so different implementations. So yeah, they're really gung-ho. It's exciting to have them on board as well as part of the team. Joseph also, he joined us this time. He actually looked at the NIST ACVP tests, so those are the standard ones NIST are doing, and generated artifacts that, or put them into a form that we can use as part of the project. So now everyone can test against, the NIST implementation as well, which is exciting. And we had some other new members, Lucas and Connor and Sean and Nick, and they're getting more familiar with it, and we'll be submitting artifacts in the future as well. So those are the major things. This is just, we still maintain the interoperability OID mapping table. There's lots of algorithms there, but if you want to do PQ interoperability testing and you need OIDs, come use our table. Then you'll be interoperable with other people. There's quite a lot of them. We have composites as well and all the standard NIST algorithms. This is an example of our compatibility matrix. It's actually being updated, probably being worked on as I speak by members. We have quite a few people that were remote as well. And as you can see, we've had a lot of team members. This is our 6th one. So a lot of new first timers this time. There's just a snapshot I took. We're at table G on the gathered. You can see there's a lot of people involved. So yeah, so that's exciting. We have monthly meetings. Our next meeting is August the 6th. So if you want to join us, you're welcome to come. We've had interim hackathons as well. Sometimes we take a Saturday and work on that. So maybe we'll have one in September. Yeah, the NIST algorithms are coming, and we have a GitHub repository. And yeah, join us. So thank you.
Thank you. It's nice to see your continued effort on working on this. Okay. Right. You're here. After DKG, we have Scrappy, the Scrappy presentation. There you go. It's best to click on.
I hold this, or
yeah.
Okay. Thanks. So this is a very short presentation. Just wanted to give a heads up that if you ever used OpenPGP, you probably run into some challenges with some of the common interfaces for dealing with it. This is just a little bit of implementation work towards making it easier to use OpenPGP, in particular to verify OpenPGP signatures, which you're likely to do if you're doing something like installing a free software operating system. I have to click this button. Look at that. Look at me button clicking. So there's a draft here that specifies a standardized interface for interacting with OpenPGP, which lets you do things like this. SOP is just the stateless OpenPGP interface. And you can do generate keys, extract certs, sign, verify, all very simple, straightforward command line options. We have multiple implementations of this. So you don't need to use fancy, weird, obscure commands like the way that the user bin PGP used to be. There is a subset of this, which is just verification only. It's useful specifically for things like installers. And the only subcommands it has are version verify and inline verify. And the semantics are it succeeds if at least one signature is valid, which is the semantics that you want in almost every case. And so you may know the GPGV implementation, which does OpenPGP verification. It is not as straightforward. It doesn't match the expected semantics. It has some weird quirks about how it deals with the file system. And so a little bit of work that I got done during the hackathon was to publish a wrapper that transforms GPGV into SOPV. So you can have a simple standards compliant verification mechanism. And so still to do is pushing that out into the broader ecosystem so we can replace GPGV implementations with a standardized interface. And I think that is my last slide. If folks are interested in this kind of work, please come let me know. This SOP implementation is the basis for the OpenPGP Working Group's interoperability test suite that the Sequoia project has done, with a great detailed view about what kinds of things are functional and interoperable in about over half a dozen implementations. So come check it out.
Thank you. Up next, Scrappy, and I think after that is the vCon. Let's see. Yeah, the other one is next here after is the vCon IETF 120.
Yes,
yeah.
That's right.
Both of yours?
Just one.
Okay, this one.
Yeah. Thank you.
Okay, there you go. Push that forward. Yeah.
Hi, my name is Thomas. I'm here to talk about the hack we did during this hackathon called Scrappy vCons. So basically what we tried to do here was two things. This is the what are we doing and why are we doing it slide. The why are we doing it is humans have the right to know how their data was processed, especially when there are robots involved. And the other is, what do we mean? So this is a quick diagram of two people in a commercial setting having a recorded conversation, then using a vCon to manage the personal information in its life cycle, the consent and the compliance. But we also added on top of that, the work that's being done by the SCIT team, which is the Supply Chain Integrity, Transparency, and Trust, so they can provide a indelible record of how that conversation was processed for the regulators and auditors and for the benefit of the customer. So this is the basic idea. vCon that's the group that I work with mostly, is the virtual conversation container. SCIT is the supply chain guys across the street, and Scrappy is what we decided to implement, which is the SCIT REST API. And so what the question we were going to ask is, do they go well together? We're both sort of new standards. Can we work? Is it peanut butter and jelly, wasabi and soy, or is it peanuts and gum? So we decided to implement that protocol and audit every vCon transformation and place it onto the ledger so that we can implement a self-serve and right-to-know service. Okay, so here's this in picture form. So we have a conserver, which is a open framework to manage vCons. They pass them back and forth. Every time it's passed, it's a transparency service. We use Scrappy to update that ledger. So at the end of the day for that vCon, you can point to that list on the right and say, this is exactly what happened to your data authoritatively. The what is, on the far end, is a schema of how we manage that log, what happened, who did it, and what's the verification that it actually happened. What we ended up doing, though, is a little bit more Big Brotherish. We took a SCIT link, a SCIT container, we ran all of our vCon links inside of it so that we didn't have to trust what that link was doing inside. So instead of having to rely on the vendors to tell us what they were doing with the information, we actually knew it because we had them surrounded. And it was very easy to implement, so that worked out pretty well too. Okay, so something that we learned, like what's in a hash. So one of the things we learned is you might not want to put a vCon on the ledger because once it's there, it ain't going away, which is almost always the wrong thing. Never say never, but that's pretty close. But also, we also understood that as vCons get transferred and processed in the network, the SHA, the hash of the payload, ends up being a very nice version-ish thing a la Git. And so there are times and places where you don't have the same version someone else does. But if you start keeping the operations and the hashes, the before and after, you can find out if you have an out-of-date vCon and ask for the next one back. That worked out very, very well. So the final one was we also implemented the right to know, right to erasure portal that we do. So if you have a bunch of vCons and you want to know if your stuff is in it, you can go get it and ask for it to be corrected or erased, as is your right. And so as we implemented this, which is the last thing we did in Australia, we added onto this the access history that was read directly off the SCIT log. Of course, that's a subject is a fake ID. We wouldn't give the real ID. And so there's a bunch of stuff we have to get to, but by and large, we learned that it was actually very awesome. It's very native to our approach. The identifiers work very well. One of the things that actually slowed us down was how well it worked together. So it wasn't clear how we should put them together because there's so many different options of how to do it. But that was really, I think, a statement towards the wideness of the use cases we could apply them to. So after we really figured out how we wanted to do it, it went like a lightning bolt. And the whole idea that we had a vCon redaction should hold up really nicely, because one of the things that we thought about in the vCon spec was how my vCon came to be from someone else before us, but we didn't track how many times that vCon was redacted for other reasons. When you add SCIT, you can have both sides and track everywhere you need to go. So finally, I want to thank a bunch of first timers this time. So we've been talking about this hack for about 3 months and really trying to understand it together. It's been a great experience for our team. So Sergey, Gordon, and Pamand and I did this all in real time in the last 24 hours, which was fun. It felt like we were young. And Josh and Benji, two new friends who helped us as well. So thank you very much for your help. And then the retreads, the people who have been here before, who've been here a lot, myself, John Geeter, Steve Lasker, and Corey Bonnell, thank you for all your help too. Thank you.
Thank you very much. All right, so next up is, let's see, Skit? Oh, vCon. Yeah, I do have slides, but it's very basic. So what's your presentation? Yeah, but I only have this version. This. So it's a template, not real slides. Try. Yeah, yeah. Okay. Okay. So I would like to invite Skit. Right. Yeah. There you go.
Thank you.
Right. And now confirm. Double check. Yeah, that looks good. I have many slides. You have
It's fine.
5 minutes.
5 minutes.
Well, I'm lenient. Yeah, 5 minutes.
Great. Okay. So great tee up from Thomas there for what we're doing. So if you don't know who Skit are, come along on Thursday at 1 o'clock or come to the Hack Demo happy hour for details. But we were trying to do lots and lots of things. We're trying to get our architecture in shape. We've been super close to publishing for ages, and we want to get those last nits out. Wanted to make sure that Scrappy actually implements the architecture that we are planning. But most of all, we wanted to prove it. So you've seen the great vCon's presentation already, which is very gratifying. And we wanted to make sure that all these clever things we've come up with actually work in practice with real code, with people who don't spend all of their lives thinking about this stuff. So here's the team. We always like to have a visual team slide. This isn't everybody, of course. AJ's at home, but has been contributing. I think we're missing Hank from this. Yeah, Hank was somebody else. But as always, a great set of people, including Corey on this slide and Thomas and his team implementing stuff. So what we got done, 25-ish, it turned out to be 22 PRs, end-to-end client code for Skit issuance, use case application engineering that I'll go through, and the very exciting vCon's thing that also got done. And what we learned, we also learned lots from doing lots. We have one huge outstanding question on Scrappy, which I think has become very clear. So again, come along on Thursday if you want to know the details, but how we connect low-level cryptographic principles to lots and lots of broad use cases needs some small but clever glue, and we did some good things there. Roles and definitions are much clearer. We did have one thing where we had bug-for-bug compatibility on incorrectly encoding COSI, so that's an interesting thing. But well, the hell, it worked. And ultimately, what we found is it is absolutely possible for regular, ordinary people who write regular, ordinary code to use Skit for their sort of software supply chain, data supply chain, and provisioning. So 22 PRs. This is already out of date. It's actually 15 now approved. So that's cool, and you can go to GitHub to see those. Scrappy issues all basically came down to the same thing, which is if I've got some data in my hands, how do I verify it? So instead of doing a big review of the document, I just wrote a bunch of code and have demonstrated that you can do all of these things. This is a standard Skit picture of I take an artifact, I turn it into a statement, I sign that statement, I get it stamped by a transparency service, and then I have a receipt so everybody can globally verify it forever. That's not interesting, that's old. What is interesting is that we're able to do this in a GitHub action, so it fits regular production workflows. We've got interoperability in time between PyCozy and GoCozy and in different implementations between the two. So you can have local signing, you can have remote signing with DigiCert, or you can have regular OpenSSL, and everything works. Use case application is very cool. So everybody's aware of what happened on July 19th. The hackers particularly are, and are trying to exploit this by sending people bad updates for their CrowdStrike and Windows machines. So basic question is, if I'm getting an update to fix my Windows machine, how do I know this thing on this USB stick is the right thing? And you can do that with Skit. That's the kind of thing that we aim to do. And Ori's kind of proven it. Go back here. He doesn't claim to have actually proven it, but he's kind of proven it. The structures we have and the way that you use Skit and Scrappy, very similar to the vCon's example, could solve this problem, could make it much clearer and less stressful for people to manage their software supply chain in an emergency situation. So there you go, tons of stuff done. Always love the hackathon. We always make a lot of progress. And yeah, again, come along tomorrow for the demo happy hour.
Thank you very much. Excellent. So, okay. So I have another presentation. Well, it's in MeTech. I think we already had the implementation, the presentation on implementation augmented by addition into Yang, I guess. So this is the third copy I have. Apologies for this. Next one is QUIC for deep space. And then thereafter, I have interface into network functions. So, okay, there you go.
Thank you. Okay.
Yeah.
Space?
No, it doesn't work. You have to click. Yeah, its focus is lost somewhere.
Okay. Deep space has very large and very variable RTT. Earth to Mars up to 45 minutes. We have been looking at using QUIC with proper transport configuration. We did it with QUIN, the QUIC stack QUIN. The good thing about QUIN was that it exposes all the necessary transport parameters we needed for our simulations. And, you know, seems to be working pretty well. However, not every QUIC stack exposed these transport config parameters in their EPI. So the goal of the hackathon was simple: to modify the QUIC stacks, some QUIC stacks, depending on the participants' knowledge of languages and stuff, to expose those parameters and then do interrupt testing between them. So we were able to modify Nico and IO QUIC. Nico is in Rust, IO QUIC is in Python. We started Cloudflare, but we haven't finished yet. We did actually some interrupt testing, as at the time of writing, it was the slide deck, it was not done, but we actually successfully interrupt testing with IO QUIC and QUIN. And thanks for the participants, Yatagai San, Robin Mueller, Laurent Toutain, and myself. And we have, if you're interested more in that generic topic of deep space IP, we have a side meeting on Wednesday morning, 8 at Tennyson. Thank you.
Thank you very much. So, excellent, thank you. Let's see if, yeah, yes, this one, yeah, this is your presentation. And
next, okay. Hello, this is John Porjang. Today, I will shortly introduce our hackathon project, Interface to In-Network Functions I2INF project. This is my graduate student collaboration work. Okay. So this is the poster for this project. Basically, the goal of this project is to demonstrate the feasibility of the framework and its interfaces. It is called I2 INF. I2 INF stands for interface to in-network functions like CoinRG. They developed the in-network computing devices like people switch and NFV failure detector. Also, we can consider barrier like security solutions. So this work is based on the draft. So I will present this OPSA session this time. So basically, you can see software-defined vehicle is nowadays very popular. Nowadays, AutoSA and the Eclipse SDV and SOPI, many the automotive car vendors are working for the automotive cars. So this project is we take advantage of their the standardization work. So we try to enable intelligent management for mobile objects like software-defined vehicle. So this time we demonstrate like the it is called the SDV user is administrator. So right hand side. So it gives some intent like the upside we have a software-defined vehicle 1 and 2. So they report their monitoring data like the mobility information, including speed. And that intent to translate into specific network policy and application policy, depending on, so network policy is for the 5G core network, like the network slicing, something like that. And the application, the policy delivered to the SDB, and then they report their speed information to SDB. Bottom side, we have cloud analyzer. So cloud analyzer collected that monitoring data and analyze using machine learning, diagnoses the car status. So this is our framework. So in the past, so we work for I2NSF for interface to network security functions. We take advantage for that experience, try to generalize to enable intent-based networking for mobile object. So this architecture, you can refer to this bottom side, the draft describe in detail. So what we learned, we implemented I2 INF framework for software-defined vehicle. So we're using just emulation, but so in future we try to using robot car, using robot OS ROS version 2, and we can demonstrate maybe a next hackathon. So also we demonstrated intent-based networking, the simple translation for compilation and monitoring for SDB. So this is the snapshot for our I2 INF framework. So we shared our open source. You can access this project. Also, we uploaded video clip. You can okay, you can see the video demonstration. So next time, so IETF 120. So we will design and develop intent translator for this framework for intent-based networking IBM. Also, we can design a young data model for our work. So this is our team. So the professors and the student, we collaborated for this weekend. Thank you.
Thank you very much. So now we come to the last presentation of vCon. So we updated. Let's see if I can find it now. Yeah, I have a next revision. I think this one is correct.
Content?
I have content, yeah. Okay, please go ahead.
Thanks. My name is Dan Petrie, and this is our 7th hackathon for vCon, which is kind of cool. But, so actually, just a quick overview. You know, for anybody who may not know what vCon is. vCon is a container, standard container for your conversational data. And you know, your conversation may be an email thread, SMS exchange, phone call, video conference, or any combination thereof. Right? These are conversations And there's metadata, who, what, when, where, why, how, etc. That is part of the conversation, in addition to ancillary documents like a slide deck or a presentation or an NDA or a contract or something. It's relevant to the conversation. And then we take that a little bit further and can also include post-conversational analysis. So a transcript, a translation, a summary, notes, sentiment analysis, action items, anything you might want to harvest out of some machine learning or AI analysis of the conversational data. And the reason we're doing this is to ease integration. We've got contact centers where you've got to deal with all these different modes of conversations that are occurring. You want to be able to capture those in an abstract way that you can, look at this, across the board and do analysis on your conversations that are happening with your customers or other contexts as well. But so at this hackathon, we focused on a couple things here. We in the last draft, I added a CDDL schema spec to generalize from JSON format to JSON and being able to support CBOR. And so I wanted to explore that in code. And then the other thing, another portion of the vCon that I haven't explored a lot in our prior implementation efforts is the redaction object. And so we wanted to explore that a little bit more and test that out to see that, go beyond theory and actually and give it a try. So here's what we got done. We got actually. Yeah, we were able to generate CBOR vCon, I think the first time. I don't know anybody else who's got a CBOR version of the vCon, and as well as JSON, which we've been doing in the past, and able to convert back and forth between CBOR and JSON vCons. We was able to do some tweaking of the CDDL, but I'll come back to the CDL in a minute. In exploring the redaction object, we kind of discovered that it may be an interesting thing to also consider as part of the vCon effort is to maybe define a media type for redaction labeling. So taking the transcription, and trying to identifying parts of that transcription that you want to redact for various reasons, and such as personal identifiable information and things like that. But to have a media type to be able to identify what's going to be redacted is interesting because you have many different parts of the vCon you may need to redact, and so having that labeling makes it easier. You think if you got audio, video, and text, you need to be able to redact all those parts or whatever. And then we were able to do a little validation of the redaction object, but we didn't quite finish. We have more work to do there. What we learned. CDDL tools out there are a little immature. We had some problems actually trying to use their CDDL. Pieces of it at a time we could use and validate, but yet to be able to get all the constructs. And so even with some simplification of the CDDL, I'm still having difficulty. We have a few things that we have to sort out on the vCon side with CBOR tag 21 and TDate. Nothing wrong with the CBOR side of things. It's or the CDDL with respect to those two. It's more we have some sorting and thinking to do on that. As I mentioned earlier, the redaction labeling, that may be an interesting media type for us to consider to standardize. So, and well, just here's who worked on it, and some links to our code. Of course, you know, the hackathon stuff's not there yet. It'll be there soon.
Okay, thank you very much. Thank you. So, thank you all. Just to check, did everyone present their results? Everyone that uploaded the presentation? Yeah, I didn't miss someone. Okay, excellent. So, first of all, I would like to thank you all. We had a great hackathon weekend. And in particular, I would like to thank the presenters to keep very nice in time and make my life easy so I don't have to interrupt someone. I would also like to point out that, right, Monday, tomorrow, we have the Hack Demo Happy Hour. So you can present your results to the broader IETF community. It's between 6:30, 7:30 in the Regency hallway over there. You can register for the Hack Demo Happy Hour on the wiki, the Hackathon wiki. So you can find it somewhere in the menu. You can click, and there you can register that you want to have a table and want to present your results. So everybody's invited. It's fun to present your work, have discussions with other people, maybe other people here in the room, but certainly also the people that didn't were able to attend the hackathon. And there's also nice social interaction. So tomorrow. Before I close, there's the code lounge. Well, that's now a shared workspace. So just for information, you can register. You will be there working on your project through the week. That's the Brighton Constable room. And finally, before I close, I want to thank our running code sponsors. This is Ericsson, our gold sponsor, and the bronze sponsors, CNNIC and ICANN. They made the weekend available possible. They provided food, drinks, so a big thanks for our sponsors. Okay. Thank you. See you this week around. I think the data tracker pilot was quite successful. I'm not sure Barry has a headache of managing everything. But if you find some improvements for the workflow, please drop an email to the hackathon chairs how we can improve the data tracker flow. And see you around this week. Bye-bye.